discussing a paper that was published by collaboration between MIT, Berkeley, and Stanford, and NVIDIA, FoundationMotion. What's interesting about this paper is that they're tackling the learning from video problem. And the way they do that is they take videos and then they throw some technology at it. I'm going to explain the details. But the goal is to understand the motion spatial structure of the videos and then put some semantics on it and then use those learnings to fine-tune robotics training data. So what does that actually mean? What am I talking about here? The idea is like if you see a video with a person making coffee at a Starbucks, that is obviously for us humans, we see the action and then we kind of understand, okay, they're making coffee, right? Now for a robot, that's actually a little bit more complicated because the robot needs to understand the spatial structure. So the hand moves into space relative to the handle that makes the espresso. The robot also needs to understand why it's doing that, because it might have other reasons not to do it maybe in the future. Like, for example, it moves the hand towards the handle, but in another video, it doesn't move the hand towards the handle because there's a bottle in between and it doesn't want to crash the bottle. So it needs to understand these things. For us, these things are obvious, but the robot, of course, doesn't understand this. But most importantly, also, we have to tie all of this in the end to actuator information, because if you want to learn from video, you also need to understand how you eventually execute your task. So all of these components need to be in place, and that's a part of the problem of video learning. Now, the people on this paper, the reason I was so interested in this paper is because of the people on the paper. Jitendra Malik, Marco Pavone, and Trevor Darrell, three of the professors that I follow pretty closely, and then a bunch of collaborators that work with them. So again, the goal is learn from video, and the way they do this is they take segmentation technology. So there's segment anything. That's a technology out of Facebook. There's other techs. So you segment the video, and then you use that segmented information to combine it with pose estimation. So you have now sections of the video where the hand moves, and then you have pose estimation that tells the robot where exactly its arm is in space. And then you eventually add semantics to it. So you use an LLM or a VLM, some combination of that, to explain to the robot why it's doing what it's doing. So that's roughly the idea. It's unsupervised in the sense that, actually it's not unsupervised, but it's automated. So you can use millions of videos and automate the process. You don't need to manually do it. The authors start the paper with the problem of cost and in labeling videos. Now, having said that, we here at Orange Capital Partners, we have a large interest and investment in robotics. And the fundamental problem with robotics is data, because it's not the only problem, but it's like in any other AI venture, you need to have enough data to be able to train. And if you want to do end-to-end training, you need a lot of data. So training from video is one option that also Elon Musk has spoken about, and we certainly believe that that is part of the solution, if not the solution, because similarly to LLMs that have been trained on internet scale video, text, we could use internet scale video from YouTube and other videos. In fact, there's a lot of videos out there of people doing things, and if we could somehow combine those things and learn from them, then that would be great. Now, one thing that the authors are not specifically talking about is the combination of all of these video clips and the segmentation and the pose estimation with the actuators. So I'm not sure, maybe I misunderstood. The link's in the show notes, so for people who are more technical, please check out. Maybe I missed something, put it in the comments, but I don't see that link. Maybe that's something that can be done on top of this fine-tuning process, which is the end goal. So you have this segmented video data with semantics that can be used to fine-tune robot learning processes. So again, this FoundationMotion paper is a very interesting approach towards learning from video. It segments videos into spatial segments. It then gives them semantics and uses a Q&A, as a question-answer process, to add logic and the how towards a process. So let's say, how am I moving the handle of the espresso machine? Well, I'm moving my hand, grabbing the handle, turning it, and then pressing a button, and then the espresso machine works, things along those lines. To finish, I just want to sort of maybe more philosophically ask myself the question, okay, like, can we just use an end-to-end learning process here where we literally learn from video and use reinforcement learning, in other words, a reward function that just runs through the videos and learns from the videos, eventually maybe generate the your own videos in a sort of Gen AI type way and learn from there. Now, I guess this is probably the end game, but what the authors are doing here is building stepwise or waypoints, milestones towards that goal. Like you want to add, they start the paper with a psychologist that talks about moving in space is what thinking is all about, or something like that. I think we've heard that before. Actual intelligence means understanding space and moving around in space. And this paper actually solves that problem. It adds the intelligent part of moving in space. In other words, it explains to the robot why it's doing what it's doing while it's moving in space. And then I guess the connection towards the actuators would be, certainly an important last part that needs to be solved. But having this semantic understanding, having a segmented semantic understanding of spatial movement is an important milestone towards the foundation model for robotics. Thank you.